Chapter 4, Section 1, Triangles and Angles. A triangle is a figure formed by three segments joining three non-collinear points. We can classify triangles based on both sides and angles. These words should sound familiar to you. You've probably classified angles before. A quick review, an equilateral triangle is a triangle with three congruent sides. An isosceles triangle is a triangle with two congruent sides, and a scalene triangle is a triangle with no congruent sides. We can also classify triangles based on angles. An acute triangle is a triangle with three acute angles. Remember, acute means that they measure less than 90 degrees. A right triangle is a triangle with one right angle. Remember, a right angle measures 90 degrees. An obtuse triangle is a triangle with one obtuse angle. Remember, obtuse is greater than 90 degrees. And an equiangular triangle is a triangle with three congruent angles, or three angles that measure that have the same measure. The angle and side relationships that I want to point out very quickly about triangles is that a triangle has two congruent sides if and only if it has two congruent angles. So notice below, I could say that the first triangle is an acute triangle, but notice that they've also told me that two of the angles are congruent. Because I am told that two of the angles are congruent, I know that the two sides that are opposite from those two angles are also congruent. So notice opposite means that it's across from the angle. On the second triangle, I am told that I have two congruent sides, which means that I have two congruent angles. Notice again, they're the angles that are opposite of the given sides that are congruent. This also works when we have three congruent sides and three congruent angles. A triangle has three congruent sides if and only if it has three congruent angles. So on the first triangle here, I'm told that I have three congruent angles, which means I have three congruent sides. And on the second triangle, I am told that I have three congruent sides, which means I have three congruent angles. The first example asks me to classify the triangle. Notice this is triangle ABC. A, B, and C all have a measure of 60 degrees, which means that all of these angles are congruent. Because all of the angles are congruent, I can say that this triangle is equiangular. But I can also say that this triangle is equilateral because I just said that if a triangle has three congruent angles, it also has three congruent sides. You always classify a triangle based on both sides and angles. So you should have two words classifying every triangle that you are asked to classify. The parts of a triangle, we have a vertex, each of the 3 points joining the sides of a triangle. So in the last example, our vertices would have been A, B, and C. Adjacent sides are two sides that share a common vertex in a triangle, or you can think of them as the two sides of the angles being formed. A right triangle. In a right triangle, the sides that form the right angle are called legs, and the side opposite of the right triangle, angle is called the hypotenuse. And for an isosceles triangle, in an isosceles triangle, the two congruent sides are called legs, and the third side is called the base. This next example, we are given, it looks like a bridge, but notice that they're highlighting triangle MNO because they've told me that the vertex N is a right angle, and they've also told me that sides NO and sides NM measure 16 feet. A asks me to explain why triangle MNO is an isosceles right triangle. Really quickly, I want to point out the notation. It says explain why, and then there's a triangle symbol. That is red triangle MNO, and notice that you name a triangle based on the three vertices. So here my vertices are M, N, and O, so I can write, instead of having to write out the word triangle, I can just draw a triangle and then name the 3 vertices of that triangle to name it. Triangle MNO is an isosceles right triangle because, first of all, it has 2 congruent sides. They tell me that ON and NM measure 16 feet, and it also has a right angle. Isosceles is naming it because of the 2 congruent sides, and right is naming it because of the 1 right angle that is in that triangle. B asks me to identify the legs and the hypotenuse of triangle MNO. Which side is the base of the triangle? So first of all, the legs would be NO and NM, because those are the 2 sides that are forming the right angle, angle N. And the hypotenuse would be side MO, because side MO is opposite of the right angle. Now, it also asks me which side is the base of the triangle. Remember, the base of an isosceles triangle is the side that is not congruent to another side. So in this case, the base is also MO. So in this case, we have the hypotenuse MO, and MO would also be considered the base of this isosceles triangle. Interior and exterior angles. When the sides of a triangle are extended, new angles are formed. Interior angles are on the inside of a triangle, or the original angles to the triangle. Exterior angles are outside of the triangle, or the new angles that are formed when we extend the sides. Notice here I have the interior angles in red and the exterior angles in blue. The interior angles, if you ignore the blue, notice that the interior angles are forming a triangle. And notice that the blue angles are formed only when we extend the sides of the triangle. The triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. So here I have triangle ABC, and I know that because this is a triangle, the measure of angle A plus the measure of angle B plus the measure of angle C will equal 180. And the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. So here, remember, non-adjacent is going to be that it is not beside, or it is not sharing a side to the exterior angle. So in this case, the measure of angle 1 is the exterior angle. The measure of angle 1 would equal the measure of angle A plus the measure of angle B, because A and B are not adjacent to angle 1. We could not use angle C for this because angle C is adjacent or sharing a side with angle 1. The next example says find the value of x, then find the measure of the exterior angle. Notice I am given interior angles measuring x and 72 degrees, and then I have an exterior angle that is measuring 2x minus 11. The interior angles measuring x and 72 degrees are not adjacent to the exterior angle, so if I add x plus 72, it should equal the exterior angle, which measures 2x minus 11. I need to solve this multi-step equation first by subtracting x from both sides. When I subtract x from both sides, I have 72 equals x minus 11. Now to solve for x, I need to add 11 to both sides, which gives me 83 equals x. I've found the value of x. Now I need to find the measure of its exterior angle. To find the measure of the exterior angle, I actually have 2 options here. I'm going to go ahead and just plug it into 2x minus 11 because that's what they tell me the measure is. So I'm going to say 2 times 83 minus 11, which is 155 degrees. Now, the other option that I could have had is I could have said, well, the exterior angle measures the sum of the 2 non-adjacent interior angles. So I could have plugged in 83 for x degrees, so I could have said that the 2 non-adjacent interior angles measured 83 degrees and 72 degrees. Well, 83 plus 72 is 155. So either way, I would have gotten the same answer. It's also good to do both just to check your answer and make sure that you get the same thing for both, using both methods. Next is the corollary to the triangle sum theorem. A corollary is a statement that can be proven easily using the theorem. So think about the triangle sum theorem, which says that the three angles of a triangle add up to 180. So this corollary is going to follow pretty closely. It's not very difficult to go from the triangle sum theorem to its corollary. It says the acute angles of a right triangle are complementary. You know that if you have a right triangle, one of the angles measures 90 degrees. You also know that you have two acute angles for the other angles of the triangle. Well, if you have one angle measuring 90 degrees, and you know that all three angles need to measure 180 degrees, you know that the two angles have to add up to 90, which means that they are complementary. So in this case, angle B is the right angle, so the measure of angle A plus the measure of angle C equals 90 degrees. The last example says the measure of one acute angle of a right triangle is 1/4 the measure of the other acute angle. Find the measure of each acute angle. Well, using the corollary to the triangle sum theorem, we know that we have a right angle, so we know that the two acute angles are going to be complementary or add up to 180. It says the measure of one acute angle of a right triangle is 1/4 the measure of the other acute angle. So if I say that the other acute angle measures x, I know that the next acute angle would measure 1/4 x. So I can say that x plus 1/4 x equals 90 degrees. I need to combine my x's. Remember, to combine these, to add fractions, you have to have a common denominator. So I could say x plus 1/4 x would be the same as 4/4x plus 1/4 x, which gives me 5/4x equals 90. Just a quick fraction, adding fractions. Remember that 4/4 would be the same as 1, so that's why that works. Now I have 5/4 x equals 90 degrees. You have two methods here. You could write 5x divided by 4. You could write it like this, and then you could multiply it by 4 and then divide by 5. Or you could just divide by 5/4, which would be, remember, the same as multiplying by 4/5. When you solve for x using either of these methods, you get 72. It asks me to find the measure of each acute angle. I know that one of the angles is measuring x, so one of the angles does just measure 72. But then to find the measure of the other angle, I need to take 1/4 of 72. 1/4 of 72 is 18. So one angle measures 72 and the other measures 18 degrees. Today's assignment is on page 198, numbers 1 through 26 all, numbers 31 through 39 odd, number 47, and then 62 through 68 even.